Hello, this video lesson is on solving a system of equations using elimination. Elimination is the third method that you are going to learn to be able to solve a system of equations. The elimination method is used to find out where the two lines cross each other. We are just going to use elimination instead of graphing. So with that said, please take out a piece of paper, make sure you have something to write with and a calculator, and I'm going to go ahead and get started. Okay, elimination is a method for solving a system of equations where we add the two equations together so that one of the variables will drop out. Sometimes the system we are given is set up to do elimination, and sometimes we may need to change either one of the equations or both of the equations so that we can make that happen. When you are solving a system of equations using elimination, you want to make sure that the two equations are stacked up on top of each other with all of the variables lining up and the constants lining up. So we can see that right here we have the x terms, right here we have the y terms, and right here we have the constants. So this system right here is already set up to do elimination. When we add these two equations together, negative 4x plus 4x leaves us with 0. Those two cancel out. When we take negative 2y and add 8y, we get 6y, and then equals negative 12 plus negative 24, which is negative 36. Now we have an equation that has just one variable that we can solve. So 6 times y equals negative 36. To get the y alone, we have to get rid of the multiplication of 6 by dividing by 6 on both sides. So y equals negative 6. This is the y-coordinate of where these two lines cross each other at. This is the y-coordinate of our solution. Okay, in order to find the x-coordinate, we go back to either our first equation or our second equation and we use substitution. So if we take our first equation, negative 4 times x minus 2 times, instead of that y, we're going to make a substitution. We are going to plug in negative 6 because we know that y is equal to negative 6. And now we can solve for our x. Negative 2 times negative 6 is positive 12. So negative 4 times x plus 12 equals negative 12. And then we would need to subtract 12 from both sides. Negative 4 times x equals negative 24. Divide by negative 4 on both sides, and we get x equals positive 6. So that means that these two lines cross each other at 6, negative 6. And we found that solution to this system by using elimination. Okay, so I am going to show you another example where the system is already set up to do elimination. So if we have the system x minus y equals 11 and 2x plus y equals 19, we are going to add these two equations together, and when we do that, the y variable is going to drop out. 1x plus 2x is 3x, negative y plus y cancels out, and then equal to 11 plus 19, which is 30. So now we have 3 times x equals 30. To make this just an x, we would divide by 3 on both sides, so x equals 10. This is the x-coordinate of the ordered pair where these two lines cross each other at. To find the y-coordinate, we use substitution. We go back to either the first equation or the second equation, and we make a substitution for the x. So instead of the x in the second equation, we're going to plug in 10. And now we have an equation with just a y that we can solve. 2 times 10 is 20. 20 plus y equals 19. Then we would need to subtract 20 from both sides. So y equals negative 1. So the place where this line and this line cross each other, if we were to graph them on the same coordinate plane, they would cross at 10, negative 1. The solution for your system is always given as an ordered pair. Okay, so for this next example, this system is not set up to do elimination. So in order to do elimination, we need to change either one equation or both equations so that when we add them together, one of the variables drop out. If you look right here, we have a negative 9y and a negative 9y. If one of those were a positive 9y, when we add positive 9y and negative 9y together, that would drop out. So we can make this negative 9y a positive 9y by multiplying it by negative 1, which means that we are going to multiply everything in the top equation by negative 1. So that'll give us a positive 2x, a positive 9y, and a positive 25. Okay, so we had to multiply everything in the equation by the same thing to keep it equal. And because we wanted this right here to be a positive 9y, that's how we knew what to multiply all of the terms in the equation by. Okay, so now we can do elimination. We can add our second equation with our new first equation. Negative 4x plus 2x is negative 2x. Negative 9y plus 9y cancels, equal to negative 23 plus 25, which is 2. And then we would divide by negative 2 on both sides, and we get x equals negative 1. Okay, now once we know what our x is, we can use substitution to figure out what our y is. We can go back to our original first equation, or we can go back to our second equation, or we can go back to our new equation to do our substitution. So pick whatever one you think is going to be the easiest. I'm just going to pick the new first equation. So we write the equation just like it is, but instead of the x, we're going to make a substitution. We know that the x is equal to negative 1. Okay, so then from there, we would add 2 to both sides. 9y equals 27, divide by 9, and we get y equals 3. So the ordered pair of where these two lines cross each other at is negative 1, 3. Okay, so for this next example, you can see that this system is not set up to do elimination. But we have a negative 6x and a negative 6x here. So if we were to just multiply either the top equation or the bottom equation by a negative 1, that would give us a positive 6x, which would set up our equation so that we could then eliminate. So negative 1 times negative 6 is positive 6x. Negative 1 times 6y is negative 6y. Negative 1 times 6 is negative 6. And then from there, 3y minus 6y is negative 3y. Negative 12 plus negative 6 is negative 18. And then we would divide by negative 3 on both sides. So y equals positive 6. And then to figure out what the x is, we can go back to our original first equation, our original second equation, or our new first equation. So I'm just going to pick our new first equation. So 6x minus 6 times y. 6 times 6 is 36. So 6 times x minus 36 equals negative 6. Add 36 to both sides. 6x equals 30. Divide by 6, and we get x equals 5. So the place where these two lines cross each other at is 5, 6. Okay, so for this example, we have negative 3x minus 9x. We have a 7y and a positive 5y. And so if we want to do elimination here, we have a couple of different options. If we wanted to eliminate the x term, we could multiply the top equation by negative 3. A negative 3 times negative 3 would give us a positive 9x. Negative 3 times 7y would be negative 21y. And negative 3 times negative 16 would be a positive 48. So that's one option. We also could take, and if we wanted to eliminate the y, we could times the top equation by 5 and the bottom equation by -7. That's going to give us -15x plus 35y equals 16 times 5. Which is 80. And then the bottom one, if we multiply that one by -7, we would get positive 63x minus 35y equals 16 times -7. Which is -112. Okay? So now we could choose which one we want to use. I actually think this one is the easiest. So -9x plus 9x would cancel. 5y and a -21y would be a -16y. 16 and 48 would be equal to 64. And then we would divide by -16 on both sides. So y equals -4. And then to figure out what the x is, we can go back to either of our first equations, substitute the y. So -3 times x plus 7 times, we now know that the y is -4. So now we have -3 times x minus 28 equals -16. And we would add 28 to both sides. Sorry, I'm running out of space here. So -3x equals 12, and then we divide by -3, so x equals -4. So the solution of this system, the ordered pair where they cross, we would write as -4, -4. Okay. So that is just a brief introduction to elimination to hopefully get you caught up to where the class is if you missed today's lesson. So just remember that when you are doing elimination, you want your two equations to be able to add together so that one of your variables drops out. And sometimes you may not need to change either equation and it will already be set up to do elimination. Sometimes you may need to multiply one of the equations by something, or you may need to multiply both equations by something in order for your elimination to be able to happen. So with that said, I will continue to practice with you on this in the next lesson.